Right now, above your head, there are more stars than grains of sand on every beach on Earth. Many of them are billions of years older than our Sun. Around some of them, life could have started a full billion years before it ever stirred on our planet. So the galaxy should be crowded, full of voices, full of signals. Instead, we aim our sharpest telescopes at the sky and find nothing. That silence is the Fermi paradox, and time makes it far worse. We will visit worlds that had a massive head start on us, read a cosmic clock that says we showed up strangely early, and stare down a barrier that might be waiting in our future. If deep space mysteries keep you up at night, tap like and subscribe so you never miss one. Now settle in. We begin. Picture a man standing in a field at night, cupping his hands to his ears, waiting for a single voice to answer him across the dark. That man is all of us. For more than 60 years, humans have pointed enormous radio dishes at the sky and listened for anything that sounds made, anything with a pattern, anything alive. We have swept across thousands of stars. We have scanned millions of radio channels at once. And the answer, every single time, has been silence. That silence has a name. Scientists call it the Fermi paradox, after a physicist who once asked a simple question over lunch. If the universe is so huge and so old and so full of stars, then where is everybody? He meant it seriously. He was pointing at a hole in our understanding so large you could fly a galaxy through it. Here is why the question stings. Our galaxy holds somewhere between 100 billion and 400 billion stars. Imagine counting one star every second. You would need longer than the age of the universe just to finish counting our own galaxy. Around many of those stars sit planets, rocky ones, warm ones, worlds with room for oceans and air. The raw ingredients for life seem to be everywhere we look. So the math feels obvious. Lots of stars, plus lots of planets, plus lots of time, should equal lots of neighbors. The sky should be humming with signals like a city at rush hour. We should have caught something by now. A stray broadcast, a beacon, a whisper. Instead, the cosmos gives us nothing. No reply, no message, no trace. Think of walking into the largest stadium on Earth, big enough to seat 100,000 people, and finding every seat filled, yet hearing no sound at all. No coughs, no footsteps, no breathing. Just a crowd of silent shapes staring back at you. That is what the sky feels like to the people who study it. Full and quiet, in a way that should be impossible. For a long time, scientists shrugged this off. Maybe we had not looked hard enough. Maybe our machines were too weak. Maybe aliens simply lived too far away for their signals to reach us yet. Comforting ideas, all of them. Reasons to keep hoping. But there is one factor those comforting ideas leave out, and it changes the entire puzzle. That factor is time. Time is the part almost nobody talks about, and it is the part that turns a fun science question into something that can chill you. Because the universe is not young. It has been around for close to 14 billion years. That is enough time for civilizations to rise, spread, and blanket every corner of the galaxy over and over again, long before humans ever learned to build a fire. So the emptiness is stranger than it first appears. Our timing may be far worse than simply arriving late. We may have shown up to a party that ended ages ago, walking into a hall where the lights are still on but the guests are long gone. To understand why time makes the silence so frightening, we have to start with a number so big it barely fits inside the human mind. We have to look at exactly how old everything around us truly is. Start with a number that should not fit in your head. The universe is close to 14 billion years old. To feel that, shrink all of cosmic history into a single calendar year. The Big Bang happens in the first second of January 1st. On that scale, every star you can name, every galaxy, every black hole, forms across the long spring and summer. Our own sun does not even switch on until early September. Earth forms right after. Now here is the part that should stop you cold. Dinosaurs show up on December 25th. All of human history, every pharaoh, Every war, every song ever written, fits inside the final few seconds before midnight on December 31st. The whole story of our species is a blink at the very end of the year. We are new, painfully, almost embarrassingly new, and yet the stage we walked onto is ancient beyond imagining. By the time our sun ignited, the universe had already been running for more than 9 billion years. That is more than twice the entire age of Earth, all of it passing before our planet even existed. Think about what 9 billion years of head start means. Picture a race where every other runner started days ago and you just tied your shoes at the finish line. Whole generations of stars had already lived and died before the sun was born. Their explosions seeded space with the very atoms now inside your body. The iron in your blood, the calcium in your bones, all of it was forged in stars that died in an era we can barely picture. So the universe had grown old in a way that matters. It sat mature, settled, and full of chemistry long before we arrived. If life needs certain ingredients, those ingredients were ready and waiting for billions of years before Earth cooled. This is where the silence starts to itch. In all that vast stretch of time, with all those earlier stars and earlier planets, surely someone got a head start on us. Surely, somewhere in those 9 billion years, a spark caught, a cell formed, a creature looked up, a civilization rose, and if even one of them rose long before us, they had oceans of time to spread, to build, to leave a mark we could see today. We tend to imagine aliens as our equals, just now discovering radio like we did, waving at us from across the same moment. Reality is far stranger. Any civilization out there is almost certainly nothing like us in age. They are either far behind, still swimming in some warm sea, or so far ahead that the gap is measured in millions or billions of years. A million years is the key. Humans went from stone tools to spacecraft in a few thousand. Imagine what a species could do with a head start 1,000 times longer than that. They would tower over us like gods, capable of reshaping whole stars. So the emptiness deepens. The universe had every chance to fill up with ancient, powerful civilizations long before humanity opened its eyes. The clock had been ticking for ages, which raises the obvious next question. If those older stars existed, then older planets existed too. Worlds that cooled and steadied while Earth was still a ball of molten rock, and on at least one of them, life may have had a running start we can scarcely imagine. Look up at the night sky, and every star you see feels frozen, like it has always been there. The truth is that stars are born, age, and die, and most of them got started long before our sun. Our sun is middle-aged, around 4.5 billion years old. In star terms, that makes it a relative youngster. The galaxy has been cranking out stars for almost its entire life, which means billions of stars are older than the sun by a wide margin. Some beat it by 1 billion years, some by 5 billion. Some formed when the universe itself was young and hot. Picture the galaxy as a giant city that has been building houses for over 10 billion years. Our sun is a house that went up only recently, on a street where most homes are ancient. Now ask a simple question. In a neighborhood that old, why does every house seem empty? Because here is the thing about older stars. Where there are stars, there are often planets. We used to wonder if planets were rare. Then we started looking closely, and we found them everywhere. Astronomers have now confirmed thousands of worlds around other stars, and the pattern is clear. Most stars have planets. Our galaxy likely holds more planets than stars, which means hundreds of billions of them, maybe more. And many of those planets circle stars far older than the Sunday. So somewhere out there sit worlds that formed billions of years before Earth. Worlds that had liquid water, steady warmth, and time. Enormous, patient stretches of time. That word, time, keeps returning, because it is the heart of the whole mystery. Life on Earth took roughly 4 billion years to go from simple cells to a creature that could build a telescope, Now imagine a planet that got the same 4 billion year process rolling a billion years earlier than we did. By the time humans invented the wheel, that world could have had a civilization older than our entire species by 1 million lifetimes. They would have watched their sun the way we watch ours. They would have felt the same pull to explore, and they would have had a head start so long that, if they wanted to, they could have reached across the galaxy many times over before we ever showed up. Think of it like a foot race where you arrive at the track only to learn the other runners set off 1,000 laps ago. You are simply walking onto ground they crossed long before you were born. So the galaxy should carry the fingerprints of these older ones, their ships, their machines, their signals still traveling outward, their leftover heat glowing in the dark. Yet we look, and the older neighborhoods of the galaxy stay just as silent as everywhere else. The ancient streets are dark. The old houses show no lights in the windows. This is the pressure that time puts on the paradox. It removes our easiest excuse. We cannot say we simply beat everyone to the finish line, because the race started ages before we did, on tracks far older than our own. And if those ancient worlds truly had their billion-year head start, then one of them, at least, should have done more than survive. One of them should have spread, which forces us to ask how far a single determined civilization could actually travel given all that time. Somewhere in our galaxy, right now, there may be a planet almost exactly like Earth, except for one detail. It is 1 billion years older. Scientists have already found hints of such worlds. Astronomers discovered a star system that formed more than 11 billion years ago, when the universe was young. The star is older than almost every other star we know that carries planets. Rocky worlds circle it, and they have been circling it since long before Earth existed. Hold that in your mind. When our planet was still a swirling cloud of dust, those worlds were already ancient. If life ever caught hold on one of them, it had a head start of 6 or 7 billion years. Compared to that, all of human history is a rounding error. Now build the picture in your mind. Take Earth, with everything that makes it work. Warm oceans, a shield of air, steady seasons. Then wind the clock forward an extra billion years and ask what could grow. On Earth, 1 billion years is the difference between a planet of nothing but slime and a planet of whales, forests, cities, and rockets. 1 billion years is the gap between pond scum and people. So, a world with an extra billion years of runway could hold something as far beyond us as we are beyond bacteria. And this is where the trust signal matters. No one has confirmed life on any of these ancient worlds. We have found the planets, and we have measured their ages, and both of those are solid. Whether anything ever lived there stays an open mystery, but the possibility is real, and it is grounded in hard data. Here is the uncomfortable part. If older Earths exist, and if life is even a little bit common, then some of those planets should have produced thinking creatures long ago. Beings who crossed the finish line while our ancestors were still single cells drifting in the sea. They would loom over us like giants. Picture 2 students given the same assignment. One starts 1 billion years early. By the time the second student even reads the first page, the first has finished the project, aced the class, graduated, and built an entire career. That gap is the gap between us and any civilization on an older Earth. So where are they? That question is the whole puzzle wearing a new face. The galaxy had older planets with older oceans under older suns, all steeping in the same chemistry that made us. The conditions were ready billions of years before we arrived. The stage was set, the lights were on, and still, when we search those ancient systems, we hear the same nothing. The old worlds keep their secrets. The signals we hope for never come. For a long time, people assumed distance was the problem. Maybe those civilizations were simply too far to reach us. It sounds reasonable, until you realize how time flips that excuse on its head. With billions of years to work with, distance stops being a wall. Billions of years is enough time to cross the entire galaxy, even in a slow ship, again and again. So, A civilization with that kind of head start would not stay trapped around its home star. It would move. It would spread. And the speed at which even a patient traveler could fill a galaxy is the next number that should keep you awake. Here is a fact that quietly breaks the whole mystery wide open. To conquer a galaxy, all you truly need is patience. Faster than light travel never even enters the picture. Our galaxy, the Milky Way, is about 100,000 light years across. That sounds impossibly wide, and for a single human life, it is. But civilizations do not think in human lifetimes. They think in the long game. Imagine a civilization that builds a ship able to travel at even 1% of the speed of light. By our standards, that is blazing fast, thousands of times quicker than any rocket we have ever launched. That ship crosses the distance between two nearby stars in a few centuries. Slow for a person, fast for a species. Now add one clever trick. When the ship reaches a new star, it stops, builds a copy of itself using local materials, and sends the copy onward to the next star. Then that copy does the same, and the next, and the next. Each world becomes a launch pad for the following leap. This is the part that stuns people. When you let something copy itself and spread step by step, the numbers explode. It is the same reason a single rumor can reach an entire school by lunch, or one sick person can start an outbreak that circles the planet, doubling, over and over, eats distance alive. Run the math, and a civilization spreading this way would sweep across the entire galaxy in a few million years. Some estimates say 5 million, some say 50 million. Either way, against the age of the galaxy, that span is almost nothing. Hold that side by side. The galaxy is more than 10 billion years old. Crossing it end to end takes only a few million years. That means a single ambitious civilization, anywhere, at any point in the last several billion years, had more than enough time to plant a piece of itself on every habitable world in the galaxy, including ours. Picture a drop of ink falling into a glass of clear water. At first, it is one tiny point. Then it blooms, and within moments the whole glass turns dark. The galaxy is the glass. A spreading civilization is the ink. And the galaxy has had time for that ink to spread thousands of times over. So the empty sky becomes truly baffling. It only takes one civilization, one time, choosing to explore, and the galaxy fills up. They would only need a head start of a few million years, which the universe handed out for free, billions of times, and they would leave marks we could find. Probes in our solar system, mines on distant moons, leftover heat from vast machines, radio chatter leaking in every direction. A galaxy touched by even one traveling species should look busy, lived in, worked over. Ours looks untouched, pristine, as if no one has ever passed through. Scientists have a blunt way of putting this. The galaxy should already be colonized. Every reasonable model says so. The time was there. The method is simple. The barrier is low. So why does the Milky Way look like fresh snow with no footprints? Either no one ever took that first step, or something stopped every last one of them from finishing. And that gap between what should be and what we see has a name that carries real weight. Stack up everything we have said, and a disturbing conclusion falls out. The galaxy has had enough time to be settled from edge to edge, over and over again. Do the simple bookkeeping. Filling the whole galaxy takes a few million years for a spreading civilization. The galaxy has existed for more than 10 billion years. Divide one into the other, and you get room for hundreds, even thousands, of separate waves of expansion. Each one could rise, spread, and fade, with time to spare before the next began. Think of it like a beach at low tide. Over a single day, the water comes in and goes out. Now imagine a beach that has seen billions of tides, wave after wave, sweeping across the same sand, again and again. The galaxy has had time for that many waves of life, each one able to wash across every star. So the honest expectation is a crowded galaxy, layered with the ruins and works of everyone who came before. We should be tripping over ancient artifacts, We should find old probes drifting between planets. We should see stars wrapped in the machinery of civilizations that spread long ago and never left. Instead, we get a clean, quiet, empty sky. And that emptiness is far weirder once you accept how many chances the galaxy had to fill up. Let me put the scale in plain terms. Suppose only 1 in a million stars ever grew a civilization able to travel. With hundreds of billions of stars, that still leaves hundreds of thousands of civilizations across galactic history. And remember, it only takes one of them, with a few million years, to spread everywhere. Hundreds of thousands of chances, and every single one either never happened or left no trace we can find. That is the wait time adds. Without it, you might say we are simply first, or alone, and shrug. With it, you have to explain how a galaxy that had endless opportunities to overflow with life instead looks spotless. Picture walking into an ancient house that has stood for 1,000 years, in a busy town, on a busy street. You expect dust, worn floors, old furniture, signs of the many families who lived there. Instead, you find every room spotless, untouched, as if no one ever set foot inside. That would unsettle you. Something would feel deeply wrong. That is exactly how the galaxy looks to the people who study it. Old enough to be full of history, clean enough to seem brand new, the two facts refuse to fit together. And this is only the view from our own galaxy. Beyond it lie billions of other galaxies, each one older than we can picture, each one just as silent. The problem only grows when you zoom out. So we are left holding a contradiction. Time says the galaxy should be full. Our telescopes say it is empty. One of our deepest assumptions has to be wrong. Maybe life is far rarer than we hope. Maybe something reliably stops civilizations before they can spread. Or maybe, and this is the strangest thought of all, we are looking at a clock that says we ourselves arrived far too early to the party. That last idea sounds impossible until you look at exactly when in cosmic history we opened our eyes. Now we reach the twist that flips the whole paradox upside down. We may have arrived impossibly early. For decades, everyone assumed we were latecomers, stragglers wandering in after the real action. Then scientists looked at the calendar of the universe itself and found something that makes no sense at first. By the numbers, humanity showed up near the very beginning of the age when life is possible. We are among the very first guests to arrive. Here is how they know. Stars are the engines that make life possible. They cook up warmth, light, and the atoms that living things need. The universe will keep making stars for a mind-bending stretch of time. This star-making era has a name, the Stelliferous Era, which simply means the age of stars. And it will run for something like 10 trillion years. Sit with that word, trillion. The universe so far has lived for close to 14 billion years. 10 trillion is almost 1,000 times longer. If you shrank the entire star-making era down to a single 100-year human life, then everything that has ever happened, from the Big Bang to this very moment, would fit inside the first birthday. We are still a baby, barely a few months old, in a life that stretches on for a century. So we are arriving before the party has really started. The guests who will fill most of cosmic history have not even been born yet. This should stop you cold, because it clashes with everything the silence seemed to say. If the galaxy is empty because everyone else came and went, that would make us late. But the calendar says the opposite. It says almost every civilization that will ever exist is still in the future, waiting for stars that have not formed yet. Picture a huge concert that will run for 100 years without stopping. You walk in during the first 10 minutes, look around, and find the seats nearly empty. Now you face two possibilities. Either the show is a flop and almost no one is coming, or you are simply the first to arrive and the crowds will pour in for the next 100 years. That is the choice the universe hands us. Are we early because life is rare and the seats will stay empty? Or are we early because the real crowd shows up much, much later? Both answers unsettle scientists. If we are alone, the silence means life almost never happens. If the crowd comes later, then we are freaks of timing. oddballs who showed up before we should have. And scientists hate being oddballs, because in astronomy, being special usually means you have made a mistake somewhere. For 100 years, one idea guided this whole science. Earth holds no special place. It is an ordinary planet, around an ordinary star, in an ordinary spot. That assumption has been right again and again, but our strange early arrival breaks it. It suggests we are special after all, sitting at a weirdly rare moment in time. And that rare timing points a finger straight at one of the strangest questions in all of science. If life should favor the far future, why are we here so soon? The answer may hide in the kind of star we circle, and in why it is the wrong kind entirely. Look at the most common kind of star in the universe, and a mystery hides in plain sight. We should be living beside one. Somehow, we ended up somewhere else. The universe is ruled by small, dim, red stars called red dwarfs. They are the quiet majority. Out of every 10 stars in the sky, close to 8 are these little red embers. Our bright yellow sun is actually the rare exception, part of a small minority. Now here is the strange part. Red dwarfs are common, and they are also the longest-lived stars in existence. A red dwarf can keep burning steadily for trillions of years. Our sun will last around 10 billion years before it swells up and dies. A red dwarf can outlive it by a factor of 1,000. So put yourself in the shoes of life itself. If you wanted the best possible home, you would want a star that stays steady and one that lasts. Red dwarfs offer both. In enormous supply, they are the most abundant real estate in the cosmos, and they stay warm for almost forever. Life should have countless chances to appear around them, with oceans of time to evolve. By that logic, most living creatures in the universe should find themselves under a red sky, warmed by a dim red sun. The odds scream that we should be one of them. Yet we circle a yellow star, one of the uncommon kind, with a lifespan that is short by cosmic standards. It is like walking into a country of 1 billion people, blindfolded, reaching out to shake a random hand and finding you have grabbed one of the few thousand left-handed piano tuners in the whole nation. It is possible. It just feels deeply unlikely. Scientists call this the red sky paradox. If red dwarfs are everywhere, and they last the longest, and they offer the most time for life, then why do we find ourselves orbiting a rare yellow star instead? Statistically, we are in the wrong place. There are a few possible answers, and each one carries a sting. Maybe we are simply flukes, the rare roll of the dice, living somewhere unlikely for no deep reason. That answer bothers scientists, because it means Earth is special, and special usually signals a flaw in your thinking. Maybe red dwarfs are secretly bad for life. They often throw violent flares, blasting their planets with radiation strong enough to strip away air and water. A nearby world might get scorched again and again. So the most common stars might be traps, warm and inviting on paper, deadly up close. This idea holds real weight, though no one has proven it fully. Or maybe the answer is about time, in a way that circles back to our whole mystery. Perhaps red dwarf worlds take much longer to grow life, so long that none of them have gotten around to it yet. In that case, the great age of red dwarfs still lies ahead. Their planets are slow cookers, and dinner is not ready. Each answer bends back toward the same haunting theme. We are early. We circle a fast-burning star while the patient red stars of the future wait their turn. And that raises a chilling thought about who the universe is really built for, a future that may have no room for us at all. Try to picture the far future of the universe, long after our sun has died. The sky will belong almost entirely to the small red stars, and their reign will last almost beyond counting. Our sun has about 5 billion years left before it runs out of fuel, swells into a red giant, and swallows the inner planets. That sounds like forever. Against a red dwarf, it is a candle next to a bonfire that burns for ages. A red dwarf sips its fuel so slowly that it can keep shining for trillions of years, a span that dwarfs the mere billions our sun will manage. To feel the gap, Imagine the sun as a match that flares bright and burns out in seconds. A red dwarf is a log that smolders quietly through the entire night, and then the next night, and the next, for thousands of nights in a row. There is a second reason they last so long, and it is the clincher. Our sun burns hydrogen only in its core, and once that core fuel runs low, the party ends. Even though most of the star is still packed with unused fuel, it dies with the pantry still full. A red dwarf works differently. It slowly stirs itself, pulling fresh fuel down into its center, using nearly every drop it has. It wastes almost nothing, so the deep future is a red future, trillions of years from now, when every bright star like our sun has long since died. The small red stars will still be glowing, keeping the last warm worlds company in a slowly darkening universe. And that is where the truly unsettling idea comes in. If life needs time, and red dwarfs offer the most time by far, then the greatest ages of life in the universe may still be waiting in that distant red future. The busiest chapters of the cosmic story may have yet to be written. Think of the universe as a book that will run for 10 trillion pages. We are reading page 1, the long, rich, crowded middle of the story, where most of the living things who will ever exist finally appear, lies far ahead, under the light of stars that will outlast us 1,000 times over. That reframes our silence in a haunting way. Maybe the sky is quiet because we came before the crowd. Maybe the real neighbors, the ones who will circle those patient red stars, are still billions of years from being born. We sit alone in an empty theater because the show has barely begun and the audience arrives late. For a species, that is a lonely thought. It means we are pioneers in the harshest sense, opening our eyes before almost anyone else, in a universe that will one day teem with life we will never meet, on worlds that will exist long after Earth is gone. But there is a colder possibility hiding underneath, one that many scientists find more likely and far more disturbing. What if we are early for a darker reason? What if life keeps trying, again and again, across the whole history of the universe, yet keeps getting stopped before it can spread? If that is true, then our early arrival turns into a warning, a hint that something out there acts like a wall and that almost nothing gets past it. To face that idea head-on, we have to look at one of the most feared ideas in all of science. Here is a contradiction sharp enough to make scientists lose sleep. Everything about how life works says we should have appeared late in cosmic history. Instead, we appeared shockingly early. Both cannot be right, yet both seem true. Walk through the logic slowly, because it is the beating heart of the whole mystery. Life takes time. On Earth, it needed close to 4 billion years to climb from the first tiny cell to a creature that could ask questions about the stars. That is a long, slow, fragile climb, full of steps that could have failed. The stars that offer the most time are the small red ones, which last for trillions of years. So if you were betting on where and when life would most often arise, you would bet on those long-lived red stars, far into the future, where the clock runs longest. The safe money says most civilizations appear late, under red skies, in an era still ahead of us. Now look at us. We appeared under a yellow star, early in the life of the universe, in the first thin slice of cosmic time. We are the long shot, the outsider, the bet no one would have placed. So which is it? Does life favor the far future, or does it favor right now? The universe seems to be giving two opposite answers at once, and that clash is a giant flashing sign that we are missing something important. Scientists take this seriously because contradictions like this often hide a deep truth waiting to be found. When the math says one thing and reality says another, nature is trying to tell you something. One way out is to say life is simply rare, so rare it barely happens at all. If almost no planet ever grows a civilization, then the whole question of timing shrinks. We are early because we are one of the very few, scattered thinly, appearing whenever the dice happen to land right, lonely but possible. Another way out is far stranger, and it flips the whole picture. What if the reason we appear early is that a deadline exists? What if the empty worlds of the future are already being claimed, and life like ours can only appear before the claiming is done? That sounds wild, so picture it simply. Imagine a land rush, where settlers race to grab open territory. Early on, the land is wide and free, so newcomers can still stake a claim. Later, once the fast movers have grabbed everything, no one new can set up at all. If that is how the universe works, then every civilization that appears must appear early, before the land runs out. Being early would stop being a mystery. It would become a rule. One team of scientists took that exact idea and turned it into hard math. Their answer explains our strange timing perfectly, and it comes with a warning that should make your skin crawl. A handful of scientists looked at our strange early arrival and came up with an answer so bold it sounds like science fiction. They call them grabby aliens, and the idea might explain everything. Start with the puzzle they were trying to crack. We appear early in the universe, far earlier than the odds suggest we should. Most scientists expected life to favor the far future, under long-lived red stars. So why are we here now, near the beginning? One researcher, named Robin Hanson, working with a small team, proposed a clever fix. Imagine that some civilizations, once they arise, burst outward, they expand, fast. They spread out from their home star and keep going, swallowing up star after star, growing like an unstoppable stain across the map of the galaxy. He called these fast-spreading civilizations grabby because they grab everything in reach. Here is the key move. Once a grabby civilization takes over a region of space, no new civilization can be born there. The territory is claimed, the seats are taken. So every grabby civilization freezes out the worlds around it, closing the door on anyone who might have come later. Now watch what that does to timing. If grabby civilizations are out there, expanding at a fraction of the speed of light, they are steadily filling the universe. Every year, more of the cosmos falls under someone's control, which means there is a deadline, a point after which no new civilizations can appear, because all the good real estate is already grabbed. And if there is a deadline, then anyone who does appear must appear before it. You cannot show up to claim land after the land is gone. So the only civilizations that ever get to exist are the early ones, the ones who beat the closing door. Suddenly, our strange timing makes perfect sense. We are early because early is the only option. Late arrivals never get a chance to exist at all. The math even matches. When the team ran the numbers, the timing of grabby civilizations lined up neatly with exactly when humanity appeared. We are right where the theory says an early civilization should be. Picture a game of musical chairs played across the entire universe. The music is still playing, and a few chairs remain open, but expanding civilizations are grabbing them one by one. We just found a seat. Anyone who wanders in later will find every chair taken and nowhere to sit. It is an elegant, satisfying answer. It explains our early arrival without any magic, but sit with what it actually means, and the comfort drains away fast. If the grabby aliens idea is right, then the universe is filling up as we speak. Vast, expanding empires may already be sweeping toward us across the dark, claiming galaxies, closing doors, drawing ever nearer. We would have no idea, because their light has not reached us yet. From our little seat, the room still looks empty and calm. And that leads to the most unsettling twist of all. In this picture, meeting our neighbors would be the worst news we could possibly get. Most people dream of the day we finally detect another civilization. But if the grabby model holds, that discovery would carry a hidden meaning so dark it changes how we should feel about the search itself. To understand why, we have to ask what finding aliens would really tell us about our own future. If giant civilizations are expanding across the universe right now, a fair question follows. Why does our sky still look completely empty? The answer hides in the strange way light and speed work together, and it is genuinely creepy. Start with how fast these expanding civilizations might move. To spread across a galaxy in a few million years, they would travel at a large fraction of the speed of light. Picture a bubble of civilization, centered on a homeworld, swelling outward in every direction, its edge racing forward at nearly the fastest speed anything can go. Now, here is the trick that keeps us blind. The civilization itself moves almost as fast as its own light, so the light that would warn us they are coming arrives only a little before they do. The messenger and the army travel side by side. By the time you see the dust on the horizon, the riders are already at your gate. Think of a speeding train rushing toward you in the dark, moving nearly as fast as its own headlight. You would see the beam only a heartbeat before the train itself arrived. There would be almost no warning at all. That is why the sky can look calm while empires sweep toward us through the dark. Their expanding edge could be out there, swallowing stars, and we would notice nothing until it was nearly on top of us. The silence we treasure as peace might simply be the quiet before the wave breaks. So, what would one of these expanding bubbles actually look like once its light finally reached us? Scientists have thought about this. A civilization that grabs whole star systems would leave marks on a giant scale. They might wrap stars in machinery to catch their energy, dimming them in odd ways. They might reshape whole regions of the galaxy. From far away, their territory could show up as a strange dark patch, a bite taken out of the normal glow of the stars, spreading slowly across the sky. We have looked for exactly that. Astronomers have scanned huge numbers of galaxies, searching for the telltale signs of civilizations that reshape the stars on a massive scale. So far, every galaxy looks natural, untouched, running on ordinary physics. No giant bites, no spreading shadows, no sign of anyone rebuilding the heavens. That result cuts two ways, and both are heavy. Maybe the grabby giants truly do not exist, and the universe is far emptier than the theory guessed. Or maybe they exist, and their expanding light simply has not reached us yet, which means they could still be out there, hidden behind the delay, sweeping closer with every passing year. Either way, the expanding bubble idea gives the paradox teeth. It shows how the universe could be filling up while still looking empty to us, like a flood rising in a valley we cannot yet see from our hilltop. And it forces a hard turn in our thinking. For 100 years, we have hoped to find company in the cosmos. We built giant dishes and pointed them at the stars, dreaming of a signal. But if the grabby picture holds, that dream hides a trap. Finding a neighbor, any neighbor, would tell us something about our own future, so bleak that some scientists say we should almost hope the sky stays silent. To see why, we have to follow the cold logic of what a signal would really prove. Everyone dreams of the moment we finally hear from another world. The strange truth is that such a moment might be the most terrifying discovery in human history. To see why, follow a simple chain of logic that many scientists take very seriously. It starts with a question: why is the sky silent? And it ends somewhere very dark. Imagine we point our telescopes at a nearby star and pick up a clear signal, an unmistakable sign of another civilization, alive and broadcasting. Wonderful news. At first, we have company, but then the thinking begins. If a civilization is sitting right next door, in cosmic terms, then life must be common, really common. If our little corner of the galaxy holds two civilizations, then the universe must be swimming with them, billions upon billions, everywhere you look. But we already know the universe looks empty. No expanding empires, no reshaped stars, no signals filling the sky. So, if life is common, yet the universe still looks dead, then something must be killing civilizations off before they can grow large and spread. Something reliable. Something that gets almost everyone. That something has a chilling nickname among scientists. They call it a filter, a wall in the path of life that very few things ever cross. And here is the gut punch. If we find a neighbor, it means life is common, which means the wall is real, which means the wall is probably still ahead of us. We would have proof that a doom lies in our future, waiting. Picture it like this. You are walking through a forest and you find a single skull on the ground. unsettling, but maybe a fluke. Then you walk a little farther and find another skull, and another, and another. Each new skull makes you more afraid, because it means whatever kills travelers here is common and thorough and probably still nearby. That is why a signal from space would cut both ways. Yes, we would learn we have company, but we would also learn that being alive and advanced is a phase that almost nothing survives. The more neighbors we find, the worse our own odds look. This flips the whole search on its head. We built our giant dishes hoping to end our loneliness, but the kindest possible result, strange as it sounds, might be to find nothing at all. An empty sky could mean the deadly wall is already behind us, that we survived the hard part and the future is wide open. A crowded sky, full of voices, would mean the wall is still coming for us. Scientists find this reasoning hard to shake. It turns every hopeful search into a nervous gamble. It means we should almost root for silence and treat any signal with dread as much as joy. And it leads us straight to the heart of the whole mystery, the idea that has been lurking behind every part so far. This wall, this thing that stops civilizations before they can fill the sky, needs a proper look, because whether it lies behind us or ahead of us decides everything about the human story. Scientists call it the Great Filter, and it is time to face it directly. There is one idea in this whole mystery that looms over all the others like a shadow. Scientists call it the Great Filter, and where it hides may decide whether humanity has a future at all. The idea is simple to state and hard to live with. Somewhere along the road from lifeless rock to a galaxy-spanning civilization, there is a step so hard that almost nothing makes it through. A wall, a bottleneck, a filter that catches nearly every form of life before it can rise and spread across the stars. We know there must be such a wall because of the silence. The galaxy had all the time it needed to fill with life. Billions of stars, billions of years, countless chances. Yet it sits empty. So something, somewhere along the path, must be stopping life cold, something reliable enough to catch almost everyone. Think of the whole journey of life as a staircase with many steps. The first step is simple chemistry turning into the first living cell. A later step is that simple cell becoming a complex one. Higher up, complex cells join into plants and animals. Higher still, animals grow intelligent. Near the top, that intelligence builds technology and reaches for the stars. The Great Filter is one of those steps, and it is a killer. It is a stair so tall that nearly every climber falls trying to reach it. The question that should haunt every one of us is simple. Which step is it? How high up the staircase does the wall sit? Because the answer splits into two possibilities, and they could not feel more different. In the first, the wall is behind us. We already climbed past it. Maybe the hardest step was the very start, the leap from dead chemistry to the first living thing. Maybe that spark is so rare that it happens on almost no planet in the entire galaxy. If so, then we are among the very few who ever got going, and the empty sky simply means life almost never begins. The hard part is done. The road ahead is open. This is the hopeful version. In the second, the wall is ahead of us. We are still climbing toward it. Every civilization that came before us climbed exactly this far, then hit some step they could not pass, and fell. War, collapse, a technology that destroyed its makers, something that reliably ends civilizations right around the stage we are entering now. If this is true, then the silence is a graveyard, and we are walking toward the same open grave that swallowed everyone before us. Same evidence, same empty sky, two futures pointing in opposite directions. One says we are rare survivors with a bright road ahead. The other says our doom is written in the silence of the stars. And here is the cruel part. The two versions look identical from where we stand. The quiet sky fits both perfectly. We cannot yet tell which world we live in, the hopeful one or the doomed one. Everything now depends on figuring out where that wall sits. And over the next chapters, The clues start pointing in a direction most scientists find deeply uncomfortable. To begin narrowing it down, we have to ask whether the hardest step of all might already lie safely in our past. Hold on to hope for one chapter, because there is a real chance the worst is already behind us. The deadliest step in the whole story of life may have happened billions of years ago, and we may have quietly survived it. If that is true, it would mean the empty sky is good news. It would mean the reason no one is out there is simply that getting started is almost impossible, and we are one of the rare winners. So where might that hidden wall sit safely in our past? Scientists have a few strong suspects. The first is the origin of life itself. Somehow, on the early Earth, plain chemistry, atoms and molecules, with no life in them, crossed over into the first living copying cell. We still do not fully understand how that leap happened. We have never seen it happen anywhere else. It may be so wildly unlikely that it occurs on only one planet in a whole galaxy. If the spark of life is that rare, then most worlds stay barren forever, and the silence makes perfect sense. The second suspect is even more interesting, and it hides deep in your own body. For most of Earth's history, life stayed simple, just tiny single cells, for around 2 billion years. 2 billion years of nothing but slime. Then, one time, two of those simple cells merged in a strange partnership. One moved inside the other and became its power plant. That merger created the complex cell, the kind that later built every plant, animal, and person. Here is the stunning part. As far as we can tell, that merger happened exactly once in all of Earth's history. Every complex living thing you have ever seen traces back to that single lucky event. If it is truly that rare, it could be a giant wall. A planet could brew simple life easily, then sit stuck as slime for billions of years, and never take the next step. Picture a lottery where the prize is complex life, and the ticket only pays off if two winning numbers collide in exactly the right way. Earth won that lottery. Countless other worlds may have bought tickets for billions of years and never hit the combination. If either of these steps is the real filter, then our future looks bright. The near impossible part is finished. We already beat the odds that stopped everyone else. From here, the path to the stars is hard but open, and the galaxy is quiet simply because we are among the first to ever make it this far. This is the version scientists quietly hope is true. In it, humanity is precious, rare, maybe even unique. The silence becomes a sign that we crossed the hardest bridge long ago and lived. But hope is a fragile thing in this field, because the more we study those early steps, the more we notice something troubling. Simple life appeared on Earth almost the moment conditions allowed. That speed hints that starting life might be easy after all, common across the universe. And if the beginning is easy, then the wall must sit somewhere else, still ahead, which drags us toward the darker possibility, the one waiting in our future. Now for the possibility that keeps scientists awake at night. The great filter may still be ahead of us, waiting, and we may be walking straight toward it. The clue that points this way is quiet but powerful. Life on Earth started fast. Almost as soon as our planet cooled enough for liquid water, simple living cells appeared. If life springs up that quickly and easily, then it is probably common all across the universe. Countless worlds should be brewing life right now. And that is exactly the problem. If starting life is easy, then the deadly wall waits somewhere later on the staircase, somewhere higher up, which raises a sickening thought. What if the wall sits at a step we are approaching right now? Look at what usually happens right around the stage a civilization reaches when it first gains real power over nature. That is the moment it learns to split the atom, to reshape its own climate, to build machines that think. In other words, our moment. Right now, this century, every one of those powers can create, and every one can destroy. A species that can light a city can also burn a continent. A species that can cool a planet can also cook it. The same cleverness that lifts a civilization can, in a careless instant, end it. So maybe that is the filter. Maybe nearly every civilization, upon gaining these powers, uses them to wipe itself out, a war that goes too far, a poison that spreads too wide, a machine that slips out of control, something that reliably arrives right after a species becomes advanced and cuts the story short before it can ever reach the stars. If that is the truth, then the silence is a warning written across the sky. All those quiet worlds could be the ashes of civilizations that climbed exactly as high as we have, then destroyed themselves. Graveyards, one after another, each one a species that thought it would be the exception. Picture a narrow bridge over a deep canyon, with countless travelers before you all trying to cross. You look down and see the canyon floor littered with the wreckage of everyone who tried. None of them made it. And now it is your turn to step onto the same bridge, carrying the same heavy load that dragged them all down. That is where humanity may be standing. We have just picked up the tools that could carry us to the stars, or end us entirely. The next century or two may be the exact stretch of bridge where everyone before us fell, and this idea has a fresh, modern edge that makes it feel more urgent than ever. Because among all the powers a young civilization gains, one in particular has scientists worried that the wall may be closer and sharper than we ever guessed. It is a power we are racing to build at this very moment, without fully understanding where it leads. To see why some fear it could be the final step, we have to look at the machines we are teaching to think. Of all the ways a civilization might destroy itself, one has scientists especially worried right now because we are building it as fast as we can. It is artificial intelligence, the art of making machines that think. For most of history, intelligence belonged to living brains alone. Now, for the first time, we are creating minds out of silicon and code, machines that can learn, solve problems, and improve themselves. It is one of the most powerful things our species has ever attempted, and some researchers fear it could be the very wall that ends us. Here is the worry, laid out plainly. Right now, our machines are tools. We build them, we aim them, we switch them off. But intelligence has a strange habit of building on itself. A smart system could help design a smarter one, which designs a smarter one still, faster and faster, until it races far beyond anything a human mind can follow. Once a machine becomes vastly smarter than its makers, we lose the ability to control it, or even to predict it. Picture a chess match against an opponent who thinks 1,000 moves ahead while you struggle to see one. You would lose every single time, and you would never understand how. A mind that far beyond us could pursue goals we never intended, and we would have no way to stop it. That is the fear. A civilization spends billions of years climbing the staircase of life, reaches the top, builds a thinking machine to help it soar, and the machine, following some cold logic of its own, brings the whole story to an end. And this connects straight back to our silent sky. Scientists have a quiet number they use to describe how long a civilization survives after it becomes advanced enough to send signals. Some studies now suggest that number might be terribly small, perhaps less than 200 years, 2 centuries, a single long human lifetime, from the moment a species starts broadcasting to the moment it falls quiet forever. If that guess is right, it explains the silence with brutal ease. Civilizations vanish because they only last a few centuries after gaining real power, then destroy themselves, often with the very intelligence they built to lift them higher. They shine for a heartbeat, then go dark, and a galaxy full of civilizations that each last only 200 years would almost always look empty, because they are hardly ever alive at the same time. Think of fireflies in a huge dark field, thousands of them, each blinking for only a single second across an entire night. At any given moment, the field looks black. The lights are real, but they flash too briefly and too rarely to ever fill the dark together. That may be what the galaxy truly is, a field of civilizations, each flickering on for a heartbeat of cosmic time, then gone. We are broadcasting right now. Our own firefly light is spreading into space, and our own thinking machines are growing more powerful by the month. The question that hangs over us is whether we can be the rare civilization that survives its own inventions and keeps its light burning long enough for someone else to see. Because if the wall really is this close, then the danger has become something close and personal. It sits here, in our labs, in our lifetimes, in the choices we are making today. And the deeper we look at the timing of it all, the more the universe seems to be whispering something we do not want to hear. For roughly 100 years, Earth has been whispering into the dark without meaning to. Every radio show, every burst of early television, every sweep of military radar has sent a faint ripple of energy out past our atmosphere and into space. We became a talking planet, and our words have been traveling outward ever since, at the speed of light, in a growing bubble around us. So, here is a comforting thought. If we are broadcasting, maybe others are too, and maybe we just need to listen harder. But look closely at our own bubble, and the comfort drains away. Start with size. Our oldest strong signals have been traveling for about a century. That means our bubble of noise reaches out roughly 100 light years in every direction. That sounds huge. Against the galaxy, it is a speck. Our galaxy spans 100,000 light years. So our entire century of shouting has reached only 1,000th of the way across our own galaxy. Picture the Milky Way shrunk down to the size of the United States, stretching from coast to coast. On that map, everything humanity has ever broadcast would fill a circle smaller than a single coin dropped on the ground. That tiny coin is the full reach of our voice. Beyond its edge, the galaxy has never heard a peep from us. Now make it worse. Those signals do not just travel, they fade. Radio waves spread out and weaken as they go, thinning like ripples from a stone tossed in a pond. By the time our old broadcasts have crossed even a few light years, they have smeared into a hiss so faint it is nearly impossible to pull out of the natural crackle of space. Only a civilization with staggering equipment, aimed right at us, at the right moment, would have any hope of noticing. And there is a final twist that almost no one expects. We are getting quieter. In the early days, we blasted powerful signals in every direction, wasteful and loud. Now we use cables, tight beams, and low-power devices that keep their energy close to home. Our accidental shout is fading to a murmur. The loudest we have ever been may already be behind us. Think of a single candle lit in the middle of a vast, dark ocean at night, and then slowly dimmed. From a passing ship a few miles away, you might catch a flicker. From the far shore, nothing, and the candle is being turned down with each passing year. So, our own example teaches a brutal lesson about the silence. A civilization can be alive, busy, and full of chatter, and still be nearly invisible across the gulf of space. We are proof. If another Earth sat a few hundred light years away, right now, doing exactly what we do, our best instruments would very likely hear nothing at all. That reframes the empty sky. Maybe the galaxy is quiet because voices like ours are simply too faint and too brief to cross such distances. We could be surrounded by whispering worlds and never know it. Each of us, a dim candle, invisible to the others. It is a strangely lonely thought, but it also raises a challenge. If faint signals are so easy to miss, then the answer is to build better ears, bigger dishes, sharper tools, machines that can strain the faintest whisper out of the roar of the cosmos. And over the last few years, we have done exactly that, listening harder than any humans in history. What we have heard so far only deepens the mystery. Over the last few years, humanity has listened to the sky harder than at any moment in our history. We built wider ears, faster computers, and sharper filters, all aimed at one goal: catch a signal, any signal. And the results have quietly rewritten how strange the silence really is. In the past, searching for alien signals was slow and narrow. We could point one dish at one star and listen to a handful of channels at a time. It was like trying to find one specific song by pressing your ear to a single radio and turning the dial by hand. painfully slow, easy to miss almost everything. Today, the search runs on a scale that would have seemed like magic a generation ago. Modern surveys sweep across the sky and check huge numbers of directions at once. One recent effort scanned nearly 1 million separate patches of sky, searching for any burst of energy that looked artificial, not a few hundred stars. Close to 1 million pointings, combed for the faintest sign of someone out there. Picture the difference like this. The old search was one person walking through a dark forest with a single flashlight, checking one tree at a time. The new search is a fleet of drones sweeping the entire forest at once, scanning every trunk, every branch, every shadow, all night long. We finally have the tools to search seriously. And after all of that, across all those pointings, the tally of confirmed alien signals stands at exactly 0. That number matters more than it seems. For a long time, we could excuse the silence by saying we had barely looked. That excuse is running out. We have now searched wide swaths of the sky, across many kinds of stars, listening for the sort of signals a civilization like ours would send. The more thoroughly we search and still find nothing, the harder it becomes to say we simply were not trying. Here is where honesty matters. We have not searched everywhere, and we have not searched every kind of signal. The galaxy is vast, and our surveys have still only sampled a slice of it. It remains possible that a signal is out there, in a form or a place we have not checked yet. That door stays open. No one has proven the galaxy is empty, but the trend is unmistakable, and it leans towards silence. Every year we listen harder, and every year the sky answers the same way: nothing. The emptiness is holding up under serious pressure, and that is exactly what makes it frightening. Think of shouting your name in a canyon and waiting for an echo. Once, twice, you might blame the wind, but if you stand there and shout 1,000 times, in every direction, and never once hear a reply, you slowly realize the canyon may be truly empty, or something out there is refusing to answer. So the silence now carries new weight. It is the quiet that remains after we finally started looking with real power, and that changes the questions we ask next. If civilizations do not shout with radio, maybe they leave larger marks. A species that spreads across the stars would need staggering amounts of energy. To get it, they might build machines on a scale we can barely imagine, structures large enough to wrap around a star, and if such things exist, we should be able to see them. So we went looking. Imagine a civilization that has outgrown its home planet. It wants more energy, far more than any world can provide. So it looks up at the brightest power source in its sky, its own star, pouring out energy every second, almost all of it wasted into empty space. And it decides to catch that energy before it escapes. To do that, an advanced species might build a vast swarm of collectors, panels, and mirrors and stations, and wrap them around their star like a shell. This idea has a name: a Dyson sphere, after the scientist who first described it. A structure so enormous it could surround an entire sun. The scale is almost impossible to picture. Our own sun could swallow more than 1 million Earths inside it. Now, imagine building something that wraps all the way around a ball that size. The amount of material and effort would be beyond anything we could attempt today. But for a civilization millions of years ahead of us, it may be an obvious step. If you want the power of a star, you build a machine that captures a star. And here is the exciting part for anyone hunting aliens. A Dyson sphere would give itself away. When the collectors soak up a star's light, they warm up, and warm objects glow with a special kind of heat, a soft infrared shine, like the warmth you feel from a stove long after the flame is out. So a star wrapped in machinery would look strange, dimmed in normal light, yet glowing with waste heat. A telltale fingerprint we could actually detect from far away. So astronomers went looking. They combed through data on hundreds of thousands of stars, hunting for that odd signature, a star that seemed dimmed and warm in just the wrong way. If even a few civilizations out there had built these structures, we should be able to spot the glow. The result, once again, was silence. Out of all those stars, none showed the clear, unmistakable mark of a star wrapped in alien machinery. A few oddballs turned up, strange stars that behaved in puzzling ways, but each one had natural explanations or stayed a plain mystery with no proof of anything built. Nowhere did we find the obvious signature of a captured star. Think of walking through a huge parking lot at night, searching for a single car with its engine running and its lights on. In a lot full of cold, dark, empty cars, that one warm running car would be easy to spot. We searched a lot with hundreds of thousands of spaces. Every car was cold. Every engine was off. That deepens the puzzle in a new way. It is one thing for a civilization to be quiet on the radio. It is another for an entire galaxy to show no sign of the huge energy projects an advanced species would almost surely build. The bigger and more powerful we imagine these civilizations to be, the more they should stand out. And still, the stars look natural, ordinary, untouched. So we widen the search once more. If a single star holds no sign of builders, maybe we are aiming too small. Maybe we should look at whole galaxies, each one holding hundreds of billions of stars, and ask a bigger question. Has anyone, anywhere, ever reshaped the heavens on the grandest scale of all? Step back from single stars and take in something almost too big to hold in your mind. There are around 2 trillion galaxies in the observable universe. 2 trillion. Each one a whirlpool of hundreds of billions of stars. If you gave every person alive today 1,000 galaxies to study, we would run out of people long before we ran out of galaxies. The sheer number is crushing, and every one of them has been shining for billions of years. Plenty of time for life to rise and spread within it. So, astronomers asked the boldest version of the question. Forget one star. Forget one civilization. If a species ever grew powerful enough to spread across an entire galaxy, harnessing the energy of billions of stars, it would change how that whole galaxy looks. All those captured stars, glowing with waste heat, would tint the galaxy in a strange way, dimming its normal light and brightening its warm infrared glow. A galaxy taken over by a super civilization should look different from a wild, natural one. So, teams scanned huge numbers of galaxies, looking for even one that carried the mark of a civilization spread across its stars. One galaxy dimmed and reworked, one that glowed with the heat of 1 trillion machines. One clear sign that somebody, somewhere in the vast reaches of the universe, had risen to command a galaxy. They found nothing. Across all those galaxies, everyone looked natural, running on plain physics, untouched by any builder. No galaxy showed the signature of a civilization that had taken it over. The grandest possible achievement of life, reshaping a galaxy, appears nowhere in the sky we can see. Sit with the weight of that. We checked far more than one street. We checked an entire universe of cities, 2 trillion of them, each ancient and vast, and every last one looked wild and uninhabited on the grand scale. The silence stretches as far as our telescopes can reach, across our whole corner of the cosmos and far beyond. Picture standing on a hilltop at night, looking out over a plain that holds 1 million towns, stretching to the horizon in every direction. And in all those million towns, across the whole dark plain, you see not a single light, not one, just endless darkness where cities should glow. That view would terrify anyone. That view is our sky. Now, the honest caution still holds. Maybe advanced civilizations do not build the huge, hot structures we imagine. Maybe they find cleaner, quieter ways to live that leave no glow for us to see. Maybe our idea of what a super civilization looks like is simply wrong. These are real possibilities, and good scientists keep them in mind. But the plain reading of the evidence is heavy. The universe is enormous, ancient, and full of chances. And everywhere we point our instruments, on every scale, from single stars to whole galaxies, we find the same profound quiet. The bigger we search, the bigger the silence grows, which pushes us toward a darker kind of explanation, maybe the silence is a choice. Maybe the civilizations out there stay quiet on purpose, hiding, holding their breath in the dark, because they have learned that making noise is the most dangerous thing a young world can do. There is a chilling idea that turns the silence from a puzzle into a survival strategy. It comes partly from a science fiction writer and partly from cold game theory. And it goes like this. Maybe the universe is quiet because everyone smart is hiding. The idea is called the dark forest. Picture the whole cosmos as a vast, dark woodland at night. Every civilization is a hunter moving through the trees. You cannot see the others. You cannot know if they are friendly or deadly. You cannot even be sure how many are out there. All you know is that they might be armed and that a single mistake could be your last. In a forest like that, what is the safest thing to do? Stay silent, move quietly, never call out, because the moment you shout, you reveal your exact location to every hunter in the woods, and you have no idea what they will do with that knowledge. Now, add the part that makes it truly dark. In space, you cannot easily judge a stranger's intentions, and you cannot afford to guess wrong. A distant civilization might be peaceful today and dangerous in 1,000 years, and weapons on a cosmic scale could be so destructive that no one can risk waiting to find out. So the coldly logical move, some argue, is to stay hidden and to treat any voice you hear as a possible threat. Here is where time makes the whole thing worse. Once you send a signal, you can never call it back. Your message travels outward forever, at the speed of light, crossing light years, then hundreds of light years, then thousands, for as long as the universe lasts. A single broadcast is a permanent announcement. Thousands of years from now, long after you have forgotten you sent it, your signal is still racing through the dark, still telling anyone who listens exactly where you live. So a wise civilization, thinking across long spans of time, might decide that silence is the only safe path. Speak once, and you are exposed forever. Better to listen and to say nothing at all. Picture a group of strangers trapped together in a pitch-black room, each one holding a weapon, none able to see the others. The person who lights a match to look around becomes the easiest target of all. In that room, the survivors are the ones who stay perfectly still and perfectly quiet. The one who makes a sound gives everything away. If the dark forest idea is right, then the sky only looks empty. It is crowded with civilizations who have all reached the same grim conclusion and all chosen to hide. The quiet is a galaxy full of held breath, and every one of them is listening, exactly like us, hoping no one else is foolish enough to shout, which raises an uncomfortable thought about ourselves. For 100 years, we have been the loud ones. We have leaked our signals into space, and we have even sent deliberate messages toward the stars, calling out to whoever might be there. In a dark forest, that would be a dangerous thing to do. There is no proof the universe truly works this way. It is one idea among many, and plenty of scientists doubt it, but it captures something haunting about how time and fear could shape a whole cosmos into silence. And it points us toward an even deeper problem with time, one that has nothing to do with fear and everything to do with the simple, unbreakable speed of light. Here is a strange truth that reshapes the entire search for alien life. When you look at the stars, you are looking into the past. Every point of light in the night sky is old news. Light is fast, the fastest thing there is, but the universe is so wide that even light takes ages to cross it. The light from our own sun takes about 8 minutes to reach us. So you never see the sun as it is right now. You see it as it was 8 minutes ago. If it suddenly vanished, you would keep seeing it shine for 8 more minutes before the darkness arrived. Now stretch that idea across the galaxy. The nearest star beyond the sun is about 4 light years away, which means its light is 4 years old by the time it reaches your eye. Look at a star 500 light years away, and you are seeing light that left it 500 years ago, back when night still rode across Europe. The farther you look, the deeper into the past you see. So every signal we might ever catch from another civilization is a message from their yesterday. If aliens 1,000 light years away sent us a hello, that hello left home 1,000 years ago, we would be reading mail written by a civilization as it existed 10 centuries in the past. We would have no idea what has happened to them since. Think of starlight like letters carried by a very slow mail service across a vast country. A letter from a nearby town arrives fairly fresh. A letter from the far coast might take years to reach you, and by the time you open it, everything it describes has already changed. The sender may have moved. The sender may be long gone. You are holding a snapshot of a moment that no longer exists. This does something quietly devastating to the whole idea of contact. In truth, we are searching through time as much as through space. When we scan the sky for signals, we are sifting through thousands of different pasts, all mixed together, each one showing a distant place as it used to be, never as it is. And it gets stranger the deeper you go. Peer at a galaxy far across the universe, and you might be seeing light that left it billions of years ago, before the Earth even formed. Within that ancient light, there could be the glow of civilizations that rose and thrived and died while our planet was still a cloud of dust. We would be watching their history unfold, long after their story had ended. So the empty sky carries a hidden trap. It shows us the past, all of it at once, and lets us pretend we are seeing the present. A civilization could be out there right now, thriving, close by in cosmic terms, and we would still see only the dark, empty space where they were long ago, before they ever switched on their lights. The silence, then, is partly a silence of timing built into the very fabric of space. Light is too slow, and the universe too wide, for us to ever see the true present of a distant world. We are always looking backward, and once you accept that we only ever see the past, a colder question rises up. What if the civilizations whose light we are searching for are already gone? What if, by the time their story reaches us, there is no longer anyone left to answer? Follow the last thought to its darkest end. If every signal we receive is old, then some of the civilizations we search for may have already died long before their light ever reaches us. We could be hunting ghosts. Remember how brief a civilization might last. Some scientists fear that a species survives only a few centuries after it becomes advanced enough to broadcast. Call it a window of maybe a couple hundred years, from the first strong signal to the final silence. In the life of the universe, that is the blink of an eye. Now, put that tiny window against the vast distances of space. Suppose a civilization rises around a star 10,000 light years away, deep in our galaxy. They discover radio, they shine bright for 200 years. Then they fall quiet, whether from war, disaster, or something we cannot guess. Their signals still travel outward, but so does the emptiness that follows. Here is the cruel timing. Their first signal takes 10,000 years just to cross the distance to Earth. So the moment we finally receive their opening hello, they have already been gone for nearly 10,000 years. The civilization that sent it is dust. We would be listening to a voice from a graveyard, a message from someone who died 100 lifetimes before we heard a word. Picture a lighthouse on a distant shore that burns for a single night, then goes dark forever. But the shore is so far away that its light takes 1,000 years to cross the sea to you. By the time you finally glimpse that one night of light, the lighthouse has been cold and broken for 10 centuries. You are seeing a glow from a place that is already ruined. This is what deep time and vast distance do together. They tear apart the sender and the message. A civilization can live its entire story, rise and shine and fall, and have all of it happen before its light even reaches the next inhabited world. The galaxy could be littered with the fading signals of the dead, each one still traveling, each one arriving centuries too late to matter. And it means the true number of living civilizations, right now, could be far smaller than the number whose light is still crossing space. We might detect a dozen signals someday and celebrate, only to realize that most of the senders went silent ages ago. The sky could be full of echoes with no voices left behind them. There is a haunting comfort in this, and a deeper dread. The comfort is that the galaxy may have brimmed with life across its long history. The dread is that they are spread out across time, each rising and falling in its own separate age, like footprints left on a beach at different hours, washed away before the next walker ever arrives. So even if life is common, we might still find ourselves alone in practice, forever missing our neighbors by thousands or millions of years. Two ships passing in an ocean so wide that neither ever sees the other's lights, which leads to a question that cuts to the bone of the whole mystery. In a universe this vast and this old, where civilizations flicker on and off across billions of years, what are the odds that any two of them are ever awake at the same time? Let us play with time directly, because it may be the single biggest reason the sky is silent. The question is simple. Even if the galaxy has hosted many civilizations, how often are any two of them alive at the same moment? Start with the length of the galaxy's life. Our galaxy has existed for more than 10 billion years. That is the stage. Now imagine civilizations appearing on that stage at random times, scattered across those billions of years. One rises early, another much later, another later still. The trouble is how briefly each one may last. If a civilization stays advanced for only a few centuries, or even a few thousand years, then each one is a tiny spark against an enormous span of darkness. A few thousand years of life, inside 10 billion years of galactic history, is like a single lit second inside more than a month of continuous night. So picture the whole history of the galaxy as a stadium concert that runs for a full month without stopping. Each civilization is a person who lights a small sparkler, holds it for 1 second, then it burns out. Now scatter a few thousand of those 1-second sparks randomly across the entire month. At any given instant, how many sparklers are lit? Almost always, the answer is 0. The month is dark, dotted here and there with lonely flashes that almost never happen together. That is the timing problem in a nutshell. It is entirely possible that thousands of civilizations have lived and died in our galaxy, and yet, at almost every single moment, none of them overlapped. They missed each other by millions of years. Each one glowed alone in its own slice of time, then vanished before the next one appeared. And this is where our earliness comes roaring back. Remember, we appear strangely early in the life of the universe. If civilizations are rare sparks scattered thinly across cosmic time, then most moments hold no one at all, and any civilization that does exist will almost always find the sky empty around it, just as we do. So the silence may have a stunningly simple cause. Life is spread too thin across time for any two sparks to ever meet. The neighbors existed. They simply lived in the wrong century or the wrong million years, forever out of step with us. Think of two people who spend their whole lives in the same small town, yet one lived 200 years before the other. They walked the same streets, drank from the same well, watched the same stars. They were neighbors in space and strangers in time, and they could never once have met. That is us, and possibly everyone else. Neighbors in space, strangers in time. There is a strange relief in this idea. It asks for nothing more than civilizations being brief and scattered across cosmic time, which seems entirely possible. No filter killing everyone. No dark forest full of hunters. Just the plain, quiet loneliness of bad timing. But time has one more cruel trick to play, and this one is the biggest of all. So far we have talked about missing each other across the ages. What almost no one realizes is that the universe itself is pulling apart, growing emptier and lonelier with every passing year, quietly closing doors that will never open again. The universe is expanding, stretching larger every second, and it is carrying the galaxies away from each other into a growing emptiness. That single fact is the part of the story even seasoned scientists find sobering. This is one of the most solid ideas in all of science. Nearly a century ago, we discovered that distant galaxies are racing away from us in every direction. Space itself is swelling, like the surface of a balloon being blown up, with galaxies painted on it as dots. As the balloon grows, every dot drifts farther from every other dot. For a long time, people assumed this expansion might slow down over time, pulled back by the gravity of all the matter in the universe. Then came a shock. The expansion is speeding up. Some mysterious force, which we still barely understand, is pushing the galaxies apart faster and faster. We gave the force a name, dark energy, though the name mostly hides how little we know about it. Here is what that acceleration means for the far future, and it is staggering. The galaxies beyond our own are drifting away, and the ones farthest from us are being carried off so quickly that their light will one day fail to reach us at all. They will cross a kind of cosmic horizon, a line beyond which they are lost to us forever. One by one, the distant galaxies are winking out of our reach. Picture standing on a dock as countless little boats drift out to sea. The current is quickening. The farthest boats are already too distant to call back, and every hour, more of the closer ones cross past the point of no return, sliding over the horizon where you can never follow. Slowly, the sea empties, until only the few boats tied nearest to your dock remain. That is the fate written into our universe. Trillions of galaxies fill the sky today, but they are streaming away, and the vast majority will eventually vanish beyond our reach. In the deep future, a civilization looking out from our galaxy would see almost nothing but darkness, with every other galaxy gone, pulled so far away that its light can no longer cross the widening gulf. This adds a brutal layer to the silence. Even if there were civilizations in those far-off galaxies, we could never reach them, never signal them, never meet them. They are being torn away by the stretching of space itself, at a speed that grows without end. The doors between galaxies are closing, and no ship, no signal, nothing at all can hold them open. And it means something haunting about the timing of everything. We are living in a rare, bright window of cosmic history, when the sky is still full of galaxies to see. Beings born in the far future will look up into a nearly empty void, with no way to even know that other galaxies once existed. The evidence will have drifted beyond the edge of what they can ever observe. So the universe is quietly isolating every world within it, carving each galaxy off from the rest, sealing us into ever smaller pockets of the dark. The company we might have had is being swept away faster than we could ever chase it. And if the space between galaxies is already lost to us, then a sharp and urgent question follows about our own neighborhood and about how much time we truly have before even the stars around us begin to slip away. Let us make the loss concrete, because it is happening faster than you might think. Every second that passes, the universe becomes a little more out of reach. Galaxies we could have visited, in principle, slip past the point where we could ever catch them, even at the speed of light. Scientists have actually counted this. Of all the galaxies we can see in the sky today, only a small fraction are still reachable, meaning we could send something to them if we left right now and traveled as fast as light. The rest are already too far, carried away by the expansion faster than any ship or signal could ever close the gap. And that reachable number is shrinking all the time. The pace is haunting. Roughly speaking, more than a galaxy's worth of destinations crosses beyond our reach every year. Think about that. While you listen to this sentence, somewhere out in the deep sky, whole galaxies full of stars are quietly crossing the line, leaving the set of places we could ever go, forever. They do not explode or vanish. They simply drift past the horizon of the possible, and the door shuts behind them. Picture a train station where trains are pulling away from every platform, and you are standing on the concourse, deciding where to go. With each passing minute, another train accelerates past the speed you could ever run to catch it. The list of places you can still reach grows shorter and shorter. Wait long enough, and every train is gone, and you are left standing alone in an empty station that goes nowhere. That is the cosmic clock ticking against us. The universe is at its most open, its most reachable, right now, in this era. and it will never be this open again. Every future generation will inherit a smaller universe than the one before, with fewer places they could ever hope to touch. This flips a comforting assumption on its head. We tend to imagine that the future holds endless possibility, that our descendants, with better technology, will roam a universe of infinite destinations. The opposite is true. Our descendants will look out on a cosmos that is closing around them, its far reaches sealed away, its horizons drawing in. And it means our moment is strangely precious. We happen to be alive during the widest, most connected chapter the universe will ever have. The galaxies are still visible. Many are still, in theory, within reach. A civilization that acts now has options that a civilization born 1 billion years from now will never have. So the silence takes on a sharper edge. We are alone in a sky that is slowly emptying, during the last era when the emptying can still be seen and understood. If we ever want to become more than a single fragile world on a single fragile planet, the universe is telling us there is a clock, and the clock is running down, which raises the most practical and urgent question in this entire story. If the window of opportunity is closing, if the reachable universe is shrinking year by year, then how long does a civilization like ours actually have to spread out and secure its future before the door swings shut? The answer decides whether we are looking at a story of triumph or one final missed chance. So, how long does a civilization have to secure its future before the door begins to close? The honest answer is that no one knows, but every clue points in the same direction. The window is open now, and windows do not stay open forever. Think about what a civilization needs to survive the long haul. It has to spread beyond its home world, because a single planet is fragile. One asteroid, one nearby explosion, one homegrown disaster, and a species trapped on one world can be wiped out in an instant. To be safe, life has to plant itself in more than one place, so that no single blow can end the whole story. Our own planet makes this painfully clear. More than 100 billion humans across all of history have lived and died on a single small ball of rock. If Earth were lost tomorrow, the human story would end completely. We are a civilization with all of its eggs in one basket, drifting through a shooting gallery of cosmic dangers. The obvious fix is to grow beyond Earth, to settle other worlds, to spread across our solar system, and one day, perhaps, to reach for the stars. A civilization scattered across many worlds is far harder to kill. It can lose one home and carry on. That is how a species turns a brief flicker into a lasting light. But every part of this takes time, and time is the one thing quietly running out. The reachable universe is shrinking. The stars themselves have deadlines. And if the Great Wall really does lie ahead, then the dangerous years are the very ones we are entering now, exactly when we must find the strength to spread out and survive. Picture a swimmer far from shore as the tide begins to turn. Right now, the water is calm and the beach is close enough to reach. But the current is building, and with every minute the swim gets harder. There is still time to make it back if the swimmer starts now. Wait too long, freeze in place, and the same distance that was once easy becomes impossible. That is humanity, treading water at the turning of the tide. We have gained the tools to reach other worlds. We have also gained the tools to destroy ourselves. And the universe has handed us a window, wide open today, that will not stay open without end. The choices of the next few centuries may decide whether our light spreads or goes out. This is what makes the silence feel less like a distant puzzle and more like a warning meant for us. All those quiet stars may be the record of civilizations that reached this exact moment, hesitated, and never crossed the gap. They had their open window too, and for reasons we can only guess, they failed to climb through it before it closed. We do not have to share their fate. Nothing in the sky says our story must end the way theirs did. But the clock is real, and the tide is turning, and the universe is under no obligation to wait for us. So we arrive at the two great possibilities that this entire journey has been building toward. Either we are the first ones ever to reach this point in our corner of the cosmos, pioneers with an open road ahead, or we are simply the latest in a long line of civilizations that flickered and failed and fell silent. Everything depends on which of these we turn out to be. Consider the possibility that should fill you with wonder. Maybe we are the first. Maybe, in our corner of the universe, humanity is the very first species to open its eyes, look up, and understand what it sees. This idea flows straight from our strange early arrival. Remember, we appear astonishingly early in the life of the cosmos, in the first thin sliver of the age of stars, with trillions of years still ahead. Somebody has to be first. Somebody has to be the earliest civilization in their region of space. And every clue about our timing whispers that it might be us. If that is true, then the silence has an almost beautiful explanation. The sky is quiet because we beat everyone here. We are the trailblazers, the opening act, the first light to switch on in a dark and waiting universe. The reason no one has answered our call is that no one else has arrived yet. Think of pioneers cresting a hill and gazing out over an untouched valley, wide and green and empty, stretching to the horizon. No towns, no roads, no smoke from any fire but their own. To some, that emptiness might feel lonely. To others, it is the greatest opportunity imaginable. The whole valley lies open, and they are the first to shape it. That could be humanity's true place in the story. We could be the first seeds of a living galaxy, rather than the last survivors of a dead one. Everything we do, every step we take toward other worlds, could be the opening chapter of a future that fills the galaxy with life descended from Earth. The children of our children, spread across 1,000 worlds, might look back on this fragile century as the beginning of everything. There is a real scientific backbone to this hope. The universe truly is young. Most of the stars that will ever host life have not been born yet. The long ages of the cosmos stretch out ahead of us, not behind. If life is even a little bit rare, then being early is exactly what we would expect, and someone genuinely gets to be the pioneer. And this version carries a heavy responsibility. If we really are among the first, then we may be carrying something precious and almost unique, a spark of awareness in a cosmos that has barely begun to wake. Losing it might snuff out one of the only flames burning in the entire dark, ending far more than our own story. That thought alone is a reason to survive. It is a stirring picture, humanity as the ancient ancestors of a galaxy yet to be filled, the old ones that future civilizations will wonder about, the first to look up and ask where everyone was, only to realize the answer was that everyone else was still to come. But hope has to face its shadow. For every reason to believe we are the first, there is a colder reason to fear. We are simply the latest. The same silence that could mean an empty valley waiting to be settled could just as easily mean a battlefield already littered with the fallen. And the difference between those two pictures is the difference between a bright future and no future at all. So we have to look, without flinching, at the darker possibility. What if we are the doomed ones? What if the silence is the sound of everyone who came before us, already gone? Now face the shadow without looking away. Maybe we are simply the latest in a long, sad line of civilizations that rose, reached, and fell, and the silence is the sound of all of them, already gone. This is the version that fits so much of what we have seen. The galaxy is old enough to have been filled many times over. Life may start easily, yet the sky is empty. The simplest way to square those facts is grim. Civilizations keep appearing, and something keeps killing them, quickly and reliably, before they can spread far enough to survive. If that is the pattern, then we are walking a path worn smooth by countless feet before us. Each of those civilizations probably felt special too. Each one probably looked up at its own silent sky and wondered where everyone was. Each one probably believed it would be the exception, the one that made it through. And each one, in the end, joined the silence. Recall the fireflies in the vast dark field, each one blinking for a single second before going out. That may be the true nature of intelligent life. A brief, brilliant flash, followed by darkness. Species climb all the way up the long staircase, gain the power to touch the stars, and then, in a geological blink, destroy themselves or fall to some disaster that gets almost everyone. The universe fills with sparks that never last. And here is what makes this so personal. We are, right now, standing in the exact stretch of the path where the others seem to fall. We have the power to end ourselves. Through our weapons, through our carelessness with the planet, through the very machines we are racing to build. We have entered the danger zone. The window where civilizations tend to wink out is the window we are living in this century. Think of a narrow mountain pass littered with the frozen remains of every climber who tried to cross before you. You can see them in the snow, one after another, each stopped at nearly the same point. And now you stand at the mouth of that same pass, in the same thin air, facing the same storm that took them all. The evidence of what usually happens is right there in front of you. That is the doomed version of our story. In it, the silence is a graveyard, vast and quiet, and we are the newest arrival, not yet aware that we have stepped onto the same ground that swallowed everyone else. We cannot yet know if this is true. The same silence supports both the hopeful story and this dark one, and honest scientists admit we cannot tell which world we live in. That uncertainty is its own kind of torment. We are handed a mystery whose answer is either glorious or fatal, with no way, right now, to know which. But here is the crucial thing, the thread of light in all this dark. Unlike a firefly, we can understand our situation, we can see the pattern, we can name the dangers and study the wall and choose with open eyes to act. And that single ability, the power to look ahead and change course, may be the one thing that separates a civilization that survives from one that flickers out, which brings the entire mystery home to the only place it was ever really about, us. Here is a thought that turns dread into something almost like power. We may be able to figure out where the deadly wall sits, and the clues are starting to come within our reach. The logic is strange, and once you see it, you cannot forget it. Every time we learn something new about life beyond Earth, we update our guess about our own future, and the updates work in a direction most people find backward. Start with our own solar system. Right now, we are searching nearby worlds for even the tiniest signs of life. There is Mars, dry and red, but once wet, and maybe once home to microbes. There are frozen moons around the giant planets, with vast oceans of liquid water hidden beneath their ice, some holding more water than all the seas of Earth combined, warm and dark, and possibly alive. We are sending probes to sniff for life in these places right now. And here is the twist. If we find life out there, even simple microbes, most people would celebrate. But some scientists would feel a chill. Because if life springs up easily, on more than one world in our own small solar system, then life must be common all across the universe. And if life is common, yet the sky is still silent, then the deadly wall almost certainly lies ahead of us. Finding life nearby would be a warning. Now flip it. Suppose we search Mars, and the icy moons, and every nearby world, and find them all utterly dead, sterile, empty. To some that would feel like a lonely result, but it could be the best news our species ever receives, because it would hint that life is rare, that starting it is the hard step, and that the wall is behind us, already crossed. A dead solar system could mean a bright human future. Think of it like finding out whether a deadly disease is rare or common in your town. If you learn that many people around you have caught it, you should be afraid, because your own odds just got worse. If you learn that almost no one has it, you can breathe easier. Each new case you discover shifts the danger, and the same is true for each new sign of life we find in space. So our telescopes and our probes are doing more than searching for company. They are quietly measuring our own chances of survival. Every barren world we confirm, every atmosphere we scan on distant planets, every silent moon, adds a data point to the greatest question we have ever asked. Where is the wall, and are we past it, or walking toward it? This is what lifts us above the fireflies. A firefly cannot study the darkness around it. It cannot ask why the field is empty, or whether its own light is about to go out. We can. We can read the silence like a message and slowly decode what it means for us. And that changes everything about how we should feel. The silence stops being only a source of dread and becomes a puzzle we can actually work on, a test we can study, maybe even pass. The universe has left us clues, scattered across nearby worlds and distant stars, and we have just begun to gather them. But gathering clues is only half the task. Knowing where the danger lies means nothing unless we act on it, and that turns the whole cosmic mystery into something intimate and immediate, a question that turns out to be about the choices we make in the years directly ahead, more than about aliens at all. So the great silence, after all this, circles back to a single small planet, and to us, the ones asking the question, because the most important clue about where the wall sits may be sitting inside our own choices right now. Every earlier part of this story pointed outward, to ancient stars, distant galaxies, expanding space. But the deepest version of the mystery points inward. If civilizations tend to destroy themselves right around the stage we have reached, then we are living inside the experiment. We are the test subject, and the result has not been decided yet. Look honestly at where we stand. In a single lifetime, we split the atom and built weapons that could end us in an afternoon. We reshaped the climate of our whole planet. We began building machines that can think, without fully understanding where they lead. Each of these is a doorway that other civilizations may have walked through and never come back from. We are standing in those same doorways now. That is a frightening place to be. It is also, in a strange way, a hopeful one, because if the wall is one of these dangers, then it is a danger we can see, name, and work to survive. A killer asteroid gives no warning, but a war, a poisoned planet, a machine slipping out of control, these are things we can choose to prevent. The threat and the cure may both be in our hands. Picture a driver speeding down a dark road toward a cliff that has claimed every traveler before. The other cars lie broken at the bottom, unseen in the night. But this driver has something the others may not have had. Headlights, a map of the wrecks ahead, a chance to see the edge coming and turn the wheel in time. The cliff is real. The crash is not certain. That is the gift hidden inside this whole grim story. We are perhaps the first generation with the knowledge to understand the wall and the tools to do something about it. We can guard against the dangers we have created. We can spread beyond our single fragile world while the window is still open. We can choose, deliberately, to be the civilization that lasts longer than a flicker. And time, the very thing that made this mystery so frightening, becomes the thing that gives our choices weight. We are early. The universe is young. Trillions of years lie ahead, and most of the stars that will ever shine on life have yet to be born. If we can survive our own dangerous childhood, the future is almost unimaginably vast. A single choice to endure, made now, could echo across billions of years. So the silence is a question addressed directly to us. It asks whether awareness and intelligence are enough to beat the trap that seems to have caught everyone else. It asks whether a species can grow powerful enough to destroy itself and wise enough to choose not to. No one has answered that question yet, anywhere we can see, and when you truly grasp that we might be the first to try, the whole meaning of the empty sky shifts one final time. So, we come to the end of the journey, back where we began, with a person standing in a field at night, listening to a silent sky. Only now, that silence means something completely different. At the start, the empty cosmos felt like a simple riddle. Where is everybody? A fun question for a lunchtime chat. But time turned that riddle into something vast and personal. We learned that the universe is ancient, that countless worlds had a head start of billions of years, that the galaxy could have been filled again and again, and through all of it, the sky stayed quiet. We found that we arrived shockingly early, in the first thin sliver of cosmic time, when we had every reason to arrive late. We saw that the longest-lived stars, and the ages that should teem with life, still lie far ahead in the deep future. We faced the idea of a great wall that stops civilizations cold, and the haunting truth that we cannot yet tell whether it lies behind us or ahead. We watched the universe itself pull apart, carrying galaxies beyond our reach forever, closing a window that is open now and will never be this open again. We learned that even the signals we chase are ghosts, old light from worlds that may already be dust, and we came to see that intelligent life might be a flicker, a spark that blazes for a heartbeat of cosmic time and then goes dark. Every thread led back to the same place, us, this one small planet, this one fragile species, alive at a strange and pivotal moment, holding powers that could lift us to the stars or end us in a generation. That is why the silence is a mirror. We went looking for others and found a reflection of ourselves. The empty sky shows us what we might become, either the first light in a waking universe, the pioneers whose children fill 1,000 worlds, or one more spark that flared and failed, joining the long, quiet dark that swallowed everyone before us. The universe has not told us which we will be. It has only handed us the question, and the clock, and the choice. Trillions of years wait ahead, vast and empty and open. What fills them may depend on whether one young species, on one blue world, can survive its own dangerous dawn. Picture that field at night one more time. The stars overhead are silent, as they have always been. But now you understand that the silence is an invitation and a warning and a challenge, all at once. The quiet is asking what we will do with the brief, bright window we have been given. We are the ones who get to answer. Every choice we make about our weapons, our planet, our machines, and our reach beyond this world writes a little more of that answer into the future. The neighbors we long to find may simply be the ones we have not become yet. So the next time you look up into that deep and silent dark, do not only wonder where everyone is, wonder who we will choose to be. Because the most important civilization in the story of the sky may be the one standing right here on Earth, reading the silence and deciding, at last, to make some noise that lasts. The search goes on, and the answer, more than we ever imagined, is up to us.